Hello and welcome to the new series, Conversations at the Intersection of Cutting Edge Science and Spirituality, with Dr. Deepak Chopra, Jennifer Hill hosting, and Professor Don Hoffman. I'm Amanda Masters, co-founder, owner, and CEO of Awake TV Network. I invite you to check out awaketvnetwork.live, where we host many videos and documentaries on science and spirituality, health and wellness, and many other modalities here to support you during these times. Enjoy the episode.
Hello, my name is Jennifer Hill, and I want to welcome you for today's episode of Conversations at the Intersection of Cutting Edge Science and Spirituality. Today's episode is Reality Beyond Space and Time with Deepak Chopra and Don Hoffman. Dr. Deepak Chopra is the founder of the Chopra Foundation, a nonprofit entity focused on research on well-being and humanitarianism, as well as Chopra Global, a medical company that is focused at the intersection of science and spirituality. Dr. Chopra is a renowned integrative medicine doctor, as well as personal development and personal transformation specialist. He has authored over 90 books, including his most recent book, Metahuman, and his latest book will be coming out later this year in September, his 91st book. Additionally, we have with us here today Don Hoffman. Don Hoffman received his PhD from MIT. He's a professor of cognitive sciences at the University of California, Irvine. He has authored over 120 scientific papers and 3 books, including The Case Against Reality: Why Evolution Hid the Truth from Our Eyes. Thanks so much for joining us today. All right, so Deepak, why don't you start us off? I know you have some great questions to throw out to Don today. Tell us what's on your mind.
Here I am again with Professor Don Hoffman, whose amazing book, The Case Against Reality, is in many ways revolutionizing how we think about everyday reality. And it's a monumental contribution to science right now, because it overthrows all of what we today understand as the scientific paradigm. So I'm going to start with some questions for Don, and we'll go from there. And my first comment and question, Don, is as I read your work, especially about evolution, you say very clearly that our senses hide the truth, that our sensory experience hides the truth, and yet, even though it's hiding the truth, it's unreliable. It is the basis for survival of the species, which is a very interesting, you're using evolutionary theory right now to contradict classical evolutionary theory. And before I actually ask you the right question, which I'm still conceiving in my mind, I want to actually make a comment. It's very obvious that our senses don't tell us the truth. You know, my senses tell me that the ground I'm standing on is stationary. I know it's spinning at dizzying speeds and hurtling through space at thousands of miles an hour. My senses tell me that everything I see that is solid is actually proportionately as void as intergalactic space. My senses tell me that the earth is flat. Nobody believes that anymore. But today I saw something in my email that came from a while back, actually. I hadn't opened that particular email. A little newsletter from an agency that works with NASA. And here is, I'm going to read it exactly, word by word, and then I have my question. Okay. So here's the newsletter. It says, you can see less than 1% of the electromagnetic spectrum. You can hear less than 1% of the acoustic spectrum. As you read this email, you're traveling at 220 kilometers per second across the galaxy. 90% of the cells in your body carry their own microbial DNA and are not you. The atoms in your body are 99.999999% empty space, and none of them are the ones you were born with. But they all originated in the belly of a star. The existence of the rainbow depends on the conical photoreceptors in your eyes. To animals without cones, the rainbow doesn't exist. So you just don't look at a rainbow, you create it. This is pretty amazing, especially considering that all the beautiful colors you see represent less than 1% of the electromagnetic spectrum. So that's a letter from NASA. Okay, and I think it reads true, but what you're saying is even more than that, that all of this, including, so first of all, our sensory experience gives us an illusory world, but even this quantum mechanical understanding is in fact, in a sense, an artifact. It's a projection of consciousness. It's part of the whole illusion. And last time when we finished, you were saying we're wearing a headset to create our virtual reality. And I thought about that afterwards. And my question to you is, even our head is part of the virtual reality. So where is this headset and what's it doing? Because our body mind is also part of the same virtual dreamscape, if I may use that word. So that's my question. And first of all, what do you think of this comment from this email from NASA?
Well, it's a beautifully written statement from NASA, and it makes a very important point. Their point is that our senses only show us a small window on reality. And I'm saying that that's actually quite a common view among my colleagues who study perception and perceptual evolution, is to say that we've evolved, of course, not to see all of the truth. We've only evolved to see those aspects of the truth that we need to survive in our niche. So for those things, you know, we'll have certain tricks and heuristics, so we'll distort things a little bit here and there, we'll miss things, but we see enough of the truth to get us by, and of course, it's a tiny fraction of all the truth. And I'm saying that if you look carefully at the mathematics of evolution, by natural selection, as it's cashed out in evolutionary game theory, and you ask the question, a very clean technical question, what is the probability that any of our senses show us any aspect of the true structure of reality? That's a clean technical question. And the answer is a clear zero. The probability is zero. So and you might say, well, how is that possible? I mean, evolution, we've been taught evolution, but natural selection assumes that there's a physical world with DNA and organisms and all that stuff. So how could you possibly use evolution to show that space and time and structures in space and time like DNA and organisms are not the truth? And that's the power of science. Because at the heart of evolutionary theory, especially evolution by natural selection, is an algorithm. And so we've written down, a guy named John Maynard Smith wrote down the foundations of evolutionary game theory. It abstracts away from all the extraneous details of evolutionary theory and gets to the algorithmic core. And that's what I and my colleagues use. We use the algorithmic core of evolutionary theory to ask a technical question. Would evolution by natural selection favor organisms that see some aspect of reality as it is, where the structures of the world get reflected in the structures of our perception? And we showed the probability of that happening is precisely zero. And that means that everything that we see, the structure of space and time, the structure of our bodies, the structure of the moon, all the structures that we see around us are not, according to evolutionary theory, are in no way telling us the structure of objective reality. Now, again, my attitude as a scientist in all this is, it's my job as a scientist to take our best current scientific theories and push them to their limits, to see what they entail. And the reason I do that is because we have no better tools, right? Our current scientific theories are the tools, the best tools that we have right now. I'm not saying that our tools are right, but we have no better tools. So I'm not saying, I'm not proposing that evolution by natural selection is the truth, but we have no better story, no better theory. So that's what we have to work with. And when we look at that theory, which is our best accepted theory, it tells us very, very clearly the probability is 0 that the structures of our perception reflect the structures of objective reality, whatever that reality might be. And I'll just give one hint as to why that's the case. It turns out that in evolution, it's about payoff functions. It's sort of like if you're playing a video game, it's how you get the points in the game, right? What do you have to do to get points in the game? In evolution by natural selection, there are these payoff functions. They depend on the state of the world, but then they give you the payoffs for your behavior in that state of the world. And so the question is, what is the probability that a payoff function will preserve the structure of the world? And what we're able to show in many, just go case after case, the payoff functions erase any information about the structure of the world. And so if you're tuned to the payoffs, you can't be tuned to the structure of the world because the payoffs don't have that information in them. They don't have the information about the structure. So that's why. That's why evolution entails that we don't see the truth. So just to reiterate your point, it's not just what NASA said, which was beautiful. What the NASA said is beautiful, that at best, and it's true, at best we see a tiny fraction of the truth. But I'm saying that evolutionary theory says something even more profound. We see none of the truth. Everything that we're seeing, according to evolutionary theory, is only telling us about the structure of the payoffs, not the structure of objective reality. And the structure of the payoffs erases information about the structure of objective reality, almost surely. So now your question about our headsets, right?
Yeah.
So what that means is that my very experience of myself as having a body is not telling me the truth about who I am. It's just another icon in my virtual reality interface. And when I look more closely, like if I look inside a body with a microscope and see brains and neurons and so forth, I'm not seeing the truth of who I am or what I'm made of. I'm just seeing a virtual reality exploration of something, according to evolution by natural selection, that's utterly unlike neurons and brains and physical stuff in space and time. Whatever it is that we're really interacting with, that we see as physical objects, particles in space and time, neurons in space and time, whatever it is we're really interacting with when we see that is not even in space and time at all. It's completely outside of space and time. And that's what evolution by natural selection is telling us. And on that point, it agrees with general relativity and quantum field theory, which together tell us that space-time is doomed. It's not fundamental. So the idea that microphysical particles and their properties and space-time and its properties are the foundation, the bedrock of all of science, and then we can build up everything from that bedrock is just rejected by our three best theories. Our theories are smart enough to tell us that space-time and microphysical particles aren't fundamental. They're not smart enough to tell us what is. And that's the fun of science. Our theories tell us where they stop, but then it takes the imagination and the creativity of the scientists to say, okay, well, what could possibly go beyond our current theories? And I'll just say, this is not just a freewheeling, whatever I want kind of thing. Whatever new theory we have that goes beyond space and time, the theory, for example, I'm talking about is one in which consciousness is fundamental. Whatever that new theory is, it's not freewheeling. When I project that theory back into space and time, I have to get back general relativity, quantum field theory, and evolution.
So as I've listened to you over the years and tried to grasp everything you're saying, I'm there with you where you are right now with what you've said. It is, of course, true that you use mathematics and use quantum theories also to reinforce your case. And right now, the math and the quantum theories, quantum mechanics, if I can summarize everything, it's impossible to, but in one sentence, everything I read from those theories says that the essential nature of reality from those theories, is that it's nothing. It's made of nothing. And yet it appears like this, the essential fundamental ontological primitive, no matter what it is, appears to be nothing. It doesn't have to have any content as such until it modifies itself into space-time and all of that, whatever we want to call it, quantum vacuum, the fundamental ground of existence, unified field, even though that's still not we don't have a unified field because of gravity and all that. But there are some big holes in that concept too. For example, as we know, the cosmological constant is off by 1 to the power of 120. It's totally ridiculous. We don't know what dark matter is. We don't know what dark energy is. Only 4% of the universe is so-called atomic, and even most of that is invisible interstellar dust. We do not know why cosmic inflation was so precise in the Planck epoch. There are so many gaps: dark energy, dark matter, cosmological constant, cosmic inflation, on and on, that actually the theories, even though they work, leave 99% of explanation out. We don't have a fundamental idea, even with these theories, of the nature of the universe. Are you suggesting that if we go a little cross the barrier from where we are, the superstition of matter, into the world that you're speaking to, that these gaps that we have, dark matter, dark energy, cosmological constant, cosmic inflation, that they actually might be solved by this new paradigm that you're exploring? And one last question. Sean Carroll, who's written a new book, he's at the University of California, not University of at Caltech, a very important physicist, has written a book recently called Something Deeper, or A Deeper Reality, or something deeper. I forget the right name right now. I have it somewhere on my desk. But basically, Sean Carroll goes with the multiverse theory all the way. So he says if you allow the Schrodinger's equation or the wave function to evolve without leaving it, the only conclusion you can get is there are infinite universes. That's his current, the book is called Something Deeply Hidden, Sean Carroll's book. And I've read it now a few times, and it's very well written, by the way. And he makes a very good mathematical case for infinite universes. Now, I was thinking, if you go with the only consciousness-only model, you could actually end up with infinite versions of virtual reality as well. And therefore, the same place, infinite versions of you, me, and everything else. In fact, Sean Carroll says there are infinite versions of you, according to his math. So where are you with all this?
Yeah, great question. So yes, of course, if going outside of space, time, and getting a deeper theory, which our theories tell us we need to do, will, if we get it right, will start to help on these problems. I should, though, say up front that my understanding is that the physicists aren't completely in the dark, like on the dark matter kind of thing. There are theories like the weakly interactive massive particles and specific predictions that if we have slightly more powerful colliders, that they can make predictions about certain energies, we should see certain signals. So they're not, it's not like they're throwing their hands up and in despair or anything like that. There's some really good and interesting work going on there. And the question of what is the universe made of, they'll say that everything comes from nothing. I don't know if they'll say that everything is nothing, but in many cases, they'll say everything comes from nothing. Many of them will say that space-time itself, even the vacuum, the empty vacuum, isn't nothing. It's something. It bends and stretches, as gravitational waves go through it and so forth. So, but they're not clear what that something is. We can describe how it vibrates when gravitational waves go through, but we don't know what space-time is. But yeah, to your other point, yes, if we go outside of space-time And where I'm going is trying to develop a mathematical model of consciousness. Then the idea would be that this mathematical model of consciousness, to be taken seriously by my scientific colleagues, I will first have to show, for example, how space-time arises. Our space-time arises, and in the case of multiverses, how multiple spacetimes might arise, or other universes in which maybe space-time isn't the right language to describe that universe. So there's different approaches that quantum physicists will go after. There's the multiverse kind of thing. There's the idea that our current universe is expanding, and the further away you get from us, the faster things are going. So that it turns out that 97% of the galaxies that we can see right now with our telescopes are moving away from us faster than the speed of light. That means 97% of the galaxies that we can see right now, there is no way for us to ever go there. This is real estate that we can never own. No matter how fast you go, you couldn't build a rocket ship that could go. So we can only get to 3% of the galaxies that we can see. And pretty soon it'll be less than that, and less, and pretty soon we won't see any galaxies that we can go to. So the universe is expanding very, very rapidly and very, very quickly. And that leads to the idea that maybe beyond our cosmic event horizon, presumably it doesn't stop. Things are just moving away. So maybe things will be very similar to what we see here in our current space-time, but maybe by the time you get to hundreds of times beyond our cosmic event horizon, the probabilities start to go up that maybe there's some changes in the laws of physics and things start to go differently there. And again, a theory of consciousness to be taken seriously will have to show precisely how our current space-time could arise, because this is the one that we can measure, right? So we have to start off with this one. And there's one thing that we absolutely have to do. This is sort of a little technical, but the one thing that we have to do is at the Large Hadron Collider and other colliders, you smash particles together, right? You like take protons, smash them together, and things go. So you might have like 2 gluons hit each other and 4 gluons go spraying out. Those are called scattering events. And we talk about their probabilities, what they call amplitudes of these scattering events. And it turns out that for a theory of quantum gravity, the only known observables that exist are scattering amplitudes. We have no other known observables for quantum gravity. So that makes a very explicit constraint on a theory of consciousness. Whatever theory of consciousness and its dynamics that I propose, or anybody proposes, if you want to be taken seriously by the scientific community, you have to show how space-time, and in particular, the structure of scattering amplitudes, arises precisely from the dynamics of consciousness. If you can't do that, you won't be taken seriously. So there's a clean test for any theory of consciousness. Show us how scattering amplitudes for Yang-Mills theory or graviton, supergraviton, whatever it might be, phi cube theory, phi to the fourth. Show me the Park-Taylor formula coming out of your theory of consciousness. If you can't do that, don't expect to be taken seriously by the scientific, the physics, in particular the physics community. But when we can do that, I mean, hopefully we can do that. I mean, I've got some ideas about how to do that, and if we can do that, that would mean that we would have a theory behind space-time that shows us how space-time arises. And presumably that would, as we I believe discussed before, possibly leave open the possibility of new technologies by which we could manipulate space-time. And that's pretty powerful.
I want to go further with what you've said right now.
Sure.
Because again, my understanding of consciousness comes from not theories of consciousness, but direct experience. Because in the Eastern wisdom traditions, they say any experience of consciousness through science, even through math, is inferential. And only direct experience of consciousness is what they call self-awareness prior to thought or transcendence. And given that, there's an ancient text in Vedanta by a great seer by the name of Vasishtha. And here's a quote from Vasishtha. He says, infinite universes come and go in the vast expanse of consciousness. Infinite universes come and go in the vast expanse of consciousness, like motes of dust dancing in a beam of light. It's a very beautiful picture. But as you read Yoga Vasishtha, what he's saying is, if consciousness is the ontological primitive, and now I'm translating into modern language, but if consciousness is the ontological primitive, then the raw material of consciousness is qualia, just like the raw material of matter is quanta. The raw material of qualia, of consciousness, is qualia, and the shuffling of qualia and the natural selection of qualia is the basis of evolution, but also the basis of multiverses or multi-universes. Now, of course, there's no math on this or anything like that, but what do you think of this idea that instead of quantum mechanics, we could create a science of qualia mechanics?
Absolutely. Absolutely. That's what I'm up to with my team. We're literally, so I've got a paper called Objects of Consciousness that anybody can go look up. It's online, it's free, with my colleague Chetan Prakash, Objects of Consciousness. We propose exactly what you talked about there. It's a mathematical model of consciousness in which qualia, or conscious experiences, are given a mathematical precise statement, and how the structure that we call a conscious agent then is what we propose is the primitive unit in this new theory of what's beyond space-time. And then we have, so it's like a vast social network, as we talked about last time, of these conscious agents, where it's so each conscious agent has these experiences, these conscious experiences that affect its choice of how it's going to influence the experiences of other conscious agents. And the whole thing is exploring all the infinite potential of consciousness, all the infinite varieties of consciousness. We mentioned Gödel's candy store, I think, last time, right? So there's this, in principle, endless exploration. There's no God smart enough to know all the possibilities. That's what Gödel's theorem is telling us. It's an infinite exploration, that even if you know an infinite amount, there's infinitely more that you don't know. So it's always boundless exploration. And so consciousness is going to always have the pleasure of exploring further into this candy store of all the possible varieties of consciousness and structures of consciousness. And so our particular world that we call, space-time and physical objects and so forth, is one of a boundless variety of forms of conscious experiences that are to be explored. And so for me, it's about, if I had to answer the question, what is it all about? The right answer is I don't know, right? As a scientist, I just have to say flat out, I don't know, and everything I could say is wrong, right? It's quite possibly that I'm wrong. But it's an interesting idea that what it's about is this endless exploration of all the possible forms of consciousness. And that's both beautiful and scary. It's beautiful because, as we know, there's many beautiful things to explore, but it's also scary because we're going into the unknown. And unknown means you don't even have the right concepts. Truly unknown means you don't have the right concepts to even grasp what's going on. So that's where, for example, in meditation, which is a form of exploration, where you go, the form of meditation in which you literally let go of all concepts. A lot of us experience a little bit of reticence to do that. It's scary. It's sort of a feeling of vulnerability and nakedness, because I don't have the defense of my concepts to hide me and so forth. So being defenseless and opening up is very, very difficult, but it's part of the exploration. So as a scientist, I want to do the mathematics and the scientific exploration, but then there's also going into the unknown, which means going into utter silence and seeing what new restructuring of my personality and what new kinds of experiences and insights might get from that.
So Don, I'll go to Jennifer in a moment. One last question, and then Jennifer can take over, because I'm sure she has a lot of questions. But the last question is, whether we call it illusion or reality doesn't ultimately matter experientially, because it feels real, right? This feels real, this room feels real, the ground feels real. And so that, by the way, is the definition of illusion. It feels real, I think. But as a physician, I have recently become very interested in virtual reality and how it alters our biological function. So, when you have somebody with anorexia nervosa, for example, an eating disorder, when they look at a mirror, they see a distorted image of themselves. And, or what we would call a distorted image, therefore they starve themselves to death. Autistic children, when they look at a mirror, do not see the facial expressions of normal emotional bonding that we all experience. So I've been doing some experimentation with VR where you can give feedback to a person where they in fact see an undistorted visual of themselves.
Nice.
Or in an autistic child, an emotionally vibrant expression through VR. And then that gives feedback to the neurons and hopefully corrects that. Also, in people with, say, burns, you can put them in a VR setting where they experience their snow, and probably that's going to be the best treatment for burns in the future. For inflammation, you can create anti-inflammatory environments, on and on. So, in 5-6 years, I think when you go to a doctor, they may not necessarily give you a pharmaceutical. They may have you go through a VR session or augmented reality to alter the biological expression of the virtual reality. So it has very practical implications. And the final question is, before Jennifer takes on, you mentioned that this understanding can lead to new technologies. So I have just mentioned one of the possible technologies. Do you have any other in mind? What kind of technologies and how will they help us? How will they create a new civilization?
Well, the new technologies will be to our current technologies. Like suppose it's, as I mentioned last time, suppose you're a wizard at some virtual reality video game, right? You know how to play the game. And that's great. I mean, that we respect someone who can really play the game, but now consider someone who actually wrote the game, who knows the software and knows how the game software is controlled by this deeper reality, which in this metaphor is the supercomputer that's driving the headset and so forth. That person then, because they know this deeper reality, how it works, and how it gives rise to what you're seeing in your VR, the space-time that you see in your VR. If you're playing, like we mentioned, an auto game, a racing game, it gives you the video of the cars and the roads and the spatial layout of everything. But now you can play with that. If you have access to the code, you can change the color of the car. You can change the shape of the car. You can change the geometry of the road. You can make the road twist. You can change the parameters of space-time. You can do whatever you want. So it's quite possible that we would get, so I mentioned that only 3% of the galaxies that are out there are accessible. That's only if we travel through space-time, because you can only go through space-time at a maximum of, near the speed of light. That's the fastest you can go. But what if we don't have to travel through space-time? We could just play with the parameters of space-time itself. Could we then have access and put ourselves to new places in the space-time? So if the world of reality is this network of conscious agents, and that's non-local, as we talked about last time, locality doesn't hold there. It's completely non-local. Locality is just a stricture on our headset. It's a structure that's imposed on our headset, but it's not part of objective reality. So we can go and do things in this non-local world and perhaps end up back in our local headset at a galaxy that otherwise would be impossible to get to. So that's, I don't have a specific, before I can tell you exactly how to do that, I have to give you, as I mentioned before, the mapping that shows how these scattering amplitudes pan out. But once we've done that, once we have, and I'll just say, I do have an idea that the long-term behavior of these conscious agents leads to positive geometries, which turn into things called amplituhedron, which physicists have now shown can give rise to these amplitudes. So I have a path from dynamics of consciousness, the asymptotic behavior, to positive geometries all the way through, but we have to work out all the math on that. That's what I'm going to be focusing on for the next couple of years. If we can get that, we get scattering amplitudes coming out of the asymptotic behavior of consciousness, then the technologies should follow. Like technologies have always followed new successes in scientific theories.
Well, this is mind-boggling, and I think once we cross the boundaries of space-time, infinite realities possibly are available to us. And I'd like Jennifer to make some comments and share with us what insights she got from this conversation. And what do you think, Jennifer, is the future of humanity with this kind of understanding of reality?
What occurs for me, gentlemen, is that the first thing we have to be aware of is that by our talking about consciousness and the mathematics of it and how we're going to go about solving the problem of consciousness, we're not actually able to get there because we're still coming from our limited perspective. And I think that through both spirituality and science and the intersection, which is what these conversations are about, that we're going to be able to remove our proverbial blinders to that which we think we can explore. To Don's point that he just made, which was brilliant, is that he can't tell you from his perspective because he's like a horse that has its blinders on right now, and those blinders are time-space. And it's only when you remove one or both of the blinders that you can then begin to have conversations of exploring the other 97% of realities and universes. And I think to make this applicable to all of our viewers and listeners out there who are tuning in now or in the future, what I would invite you to consider is while Don is working on his theory of mathematics to verify and validate that there is a theory based on consciousness, what Deepak and Don are discussing is accessible right now in the here and now by asking yourself, how could I perceive things differently? When you bring this idea of wonder to this, you know, I can kind of hear and intuit what some people are thinking. Well, Don or Deepak, if I'm living in a virtual reality, why would I choose to be impoverished? Why would evolutionary game theory, why would I be choosing this? And it's not even telling me the truth of a situation. Why would I choose that I have loved ones who are potentially dying? I know you gave it another example, Don. It's like somebody leaving the virtual reality game. It's only when we start to expand and play with the limitations, and I think perhaps that could be a future episode, is talking about the limitations and how we begin to expand that then we can tap into the infinite possibilities of who we are in every moment. And one of my teachers years ago said, it's as though every word I'm saying right now, every thought I just had as I approached the words I'm speaking, took me into different alternate realities. And when we begin to explore that we are literally the creators of everything, both mathematically, fundamentally, we can then literally ride around on rainbows, beams of light, create whatever we want. Although the question I'm interested in is how do we remove those limitations, not only scientifically, but consciously? Since we're talking about consciousness, how can we begin to expand that? Does that make sense?
Yeah, but it's brilliant. As far as I'm concerned, what you've said is totally brilliant. And if Don agrees, then we can explore in our next conversation the whole idea of identity. What is identity? If Don likes that idea based on this, because the more I hear and converse with Don and with you, Jennifer, it becomes a very pivotal issue. Is there such a thing as absolute identity, or is it all provisional anyway? What does that mean? So if Don agrees, we can do that on identity. And this particular episode, if Don agrees and you agree, we can call it Realities Beyond Space and Time. How's that? Reality Beyond Space and Time. What do you think, Don?
That's great. I like that.
Jennifer?
Yeah, I think that's a wonderful idea. And I think that the deeper we go into this too, I think that the more that we're going to expand our own consciousness and the consciousness of the whole, and we'll have to do a whole other show on holographic universes and how each one of us and the people tuning in are having an impact on one another and ourselves.
I like that a lot. And if Don is game, we continue this journey.
Absolutely.
Wonderful, gentlemen.
Jennifer.
Thank you so much for tuning in.
Thank
Thank
you
you
very
to
much.
everybody who tuned in.
We're going to call it Reality Beyond Space and Time. How's that?
Perfect.
Okay.